Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 13 of JEE Advanced Physics paper 2015. So let us move to question number 13. Students, let us solve question number 13. The question says, for photoelectric effect, this question is about photoelectric effect, modern physics. Now, in photoelectric effect with incident photon of wavelength lambda, the stopping potential is V naught. Identify the correct variations of V naught with lambda and 1 by lambda. So you have to plot the graph of V naught versus lambda as well as V naught versus 1 upon lambda. So we have got two answers because we have got two questions. Now in photoelectric effect, in Einstein's photoelectric effect, we have known that from the equation is that the energy of the incident light or incident photon h mu is equal to the work function of the metal plus the maximum kinetic energy of the ejected electron. Now we have to write this expression in terms of stopping potential, and the stopping potential depends on this value, can be related to the maximum kinetic energy. The most kinetic energy is stopped by that negative potential known as stopping potential, that is the minimum value of negative potential. So this kinetic energy can also be written as EV naught. This is the kinetic energy in terms of stopping potential, then this is the value. Now from here I can write that V naught will be equal to HC H mu minus phi divided by E and divided by E over here. So this is the equation from which we are going to plot the curve. This is the frequency of the incident light, then we have to find the expression for wavelength. Writing frequency in terms of wavelength, this will be V naught equals to H, frequency C by lambda, and E is there, minus phi over E. This is the equation number 1, and that is used to plot the curve. First let me plot the curve for this 1 by lambda, V naught versus 1 by lambda. If I take 1 by lambda as x and this was y, then this equation will be of the form y equals to some mx minus c. And we know the graph of this will be, if I take this is x and this is y, then this has negative y-intercept, negative y-intercept minus c, somewhere here say, and the graph will be something like that, with the slope equals to hc by e is the slope, and this is the value of minus c, which is equal to minus phi divided by charge of the electron. So this graph is correct. So in place of x I can put this is 1 upon lambda, and in this y-axis I'll put V naught. So this is how the graph will look like, and therefore if I see the question, this option number 3 is correct. V naught versus 1 by lambda is a linear graph with slope equals to hc by e. So this is correct for the correct option. One option is correct. Another is to plot the curve for V naught versus lambda. When you think of V naught versus lambda, our equation that we just derived, it was hc divided by e lambda minus phi by e. Now if I consider this as my x, then and this was my y, and this is any constant, say minus c, or any constant, say, we know that this is of the form, this is any some multiple constant, say we can say it is any k. So y is some k by x minus c type. If I go for the simplification, we know the curve for y equals to k by x curve. For y equals to k by x, this is a rectangular hyperbola. This is a rectangular hyperbola. If this is there, then this will touch this axis. If this is not there, this will never touch the axis. If it is there, it will touch the axis, because this can be 0 at when this will match with this. So certain value of x will put this value v0 equals to 0. So this v0, this is the graph of y is inversely proportional to x. But when you talk about this constant is added or subtracted, that will touch this axis. So therefore, if I consider this equation, then this graph of y versus x will be something like that. And this is the point when y equals to 0, y is 0 on the x-axis, and this is 0. That means this is possible when k by x is c, or x will be k by c. And in this situation, it is k by c is any constant actually, that I'll put here as this. So here it is k is my hc by e, and c is my phi by e, that is hc over phi. So this is the point which is hc over phi, and at this point the value of y is 0. Otherwise the nature of the curve will remain the same, that is hyperbolic, and this graph will be like that. If I see the curve, then these two are given. Obviously this is not possible because this is reciprocal, this is not a straight line, so this one is correct. And this point where the what value of lambda, because here in x-axis we have taken lambda, and in y-axis we have taken v0. So what value of lambda? The lambda should be hc by phi, where this v0 is 0. This point is hc by phi. This value of, when lambda is this, then v0 is 0. Stopping potential will be 0. So therefore, option number 1 and option number 3 are correct to this question. Okay, thank you.